going to ask that everybody to take their seats. We're just about to introduce our keynote speaker.
Dave Partridge, Community Manager at Potsdam. Thank you for organizing the event tonight. My name is Alex Hardy, and I'm a partner at Video Canada, and we work closely with a lot of tech companies from startup right through to IPO. And I'm the leader for the Central Canada region. Technology is one of our key focus industries, and we support the local tech community as well as supporting the museum as well through our sponsorship here. And we've really enjoyed the speakers that we've had on for the first half of the evening. For the remainder of the evening, we have a keynote speaker for everybody, and then there is a panel talking about cryptocurrency and blockchain, and probably a little bit less technical than the first half. So I think the first half was great for the developers, and then there were some business people that understood a lot of what was happening, but there were still some things that they didn't. So the second half is going to be probably less technical. So join me in welcoming our keynote speaker tonight. Our keynote speaker is Curtis McBride. And for those of you that live in town, you'd know Curtis well. He's an entrepreneur in the technology space in Kitchener-Waterloo. He's taken a vision of a more efficient way of counting traffic. He co-founded Maya Vision over a decade ago, and Maya Vision is dedicated to helping cities achieve their smart city visions, transforming traffic networks through innovation and the latest technologies. In addition, Curtis also founded Catalyst 137, which is a $475,000 square foot space, which is a hub in Kitchener for local businesses innovating in the technology and startup space. It's the world's largest Internet of Things manufacturing space. He attended the University of Waterloo, getting his Bachelor in Engineering in System Design. He co-founded Maya Vision in 2005 with two of his classmates, and he's currently the CEO of Maya Vision for the past 11 years. So I'd like to welcome Curtis McBride to the stage to talk about Maya Vision and his ideas.
Consensus for providing technology that works, because I brought some that didn't. So, I always say when I'm building companies, the goal of the CEO is to be the dumbest person at the company. So being the non-technical person presenting today, I definitely feel like the dumbest person in the room. So today I'm going to talk about an application of blockchain to a buzzword that gets used all over the place, but really doesn't mean anything, which is smart cities. So I'm going to talk a little bit about sort of how we think that blockchain might actually be part of the fundamental technology that could help the smart city actually become a thing that is real. So, but I'm going to provide some sort of macro industry trends to start this off. So one of the things that another sort of buzz phrase that you might hear getting used a lot is data is the new oil. And what this is really trying to get at is that the value of data has been going up quite a lot, even in the last 5 years with the advent of deep learning, commonly known as artificial intelligence. The whole model of how you build software has changed. It's gone from a model where you spend a lot of time developing IP, and data is kind of like the waste product of IP, to one where data is actually now used to write software, right? Artificial intelligence ingests data, ground truth, and that's how we build algorithms now. So as a consequence, the data that's out there has increased in value, but a lot of the policymakers, municipal governance folks haven't really caught up to that fact. But that's sort of one trend. I don't know how well you guys can see this, but another thing that we're seeing happen a lot is that in our personal lives, the use of technology is prolific, right? Like we can go online, we can buy something and have it delivered to our house, and on the same day. So, but in our experience of our cities, we're still living in an analog world that was built in the 80s and 90s, and so there's this expectation gap where we perceive that technology should be changing the way we live, but our cities aren't actually keeping up, and that expectation gap is growing, and you see it in elections where using technology to fix traffic is something that John Tory talks about, probably in 30% of his speeches. So how do we fix this problem, right? We have a world that is changing exponentially, and we have a tax base that is growing linearly. Do we raise taxes, and I guess then consequentially, do we raise taxes exponentially in order to pay for this? That can't be the way that we approach this problem. So there's got to be a better way. So our view is that if you can combine the fact that data is emerging as a new asset class, and if you could somehow capture the value of that data, of which cities are filled with it, right? Like as you drive home today, just look around at the built form of the city and imagine that, for every physical thing that you see that's electronic in some way, right? A traffic light, a street light, the cars moving around, us with our phones in our pockets. There's data everywhere, right? So how do we capture the value of that data and turn it into a new income stream for cities that can be used to try to close this expectation gap? One of the things that we have going for us as well, and a lot of times when I give this speech, the question comes like, give me an example of how data is valuable. So you can provide some linear examples of how traffic data can be used for to help Walmart understand where to build the next Walmart. Parking data has value in this way or that way. But one of the things that we know from our experience building the internet is that networks are valuable as a function of the square of the number of nodes in the network, right? So the bigger a network is, the more valuable each node in the network is in effect. So when we apply that to data, if we think about data as a new asset class, we think about data as almost like a commodity, right? So think of data, to extend the oil analogy, right? Think of data as a resource like oil is a resource. There was a time in human history where oil was kind of valuable, like it was kind of useful, you could burn it and do some things, but it was only really when the combustion engine came along, or plastics came along, or medicine came along, where the value of oil starts to go up, because there's all sorts of new use cases. So what we think, if we sort of apply this to the world of data from our cities, think about cities as almost like platforms, the new frontier for the internet, we think what happens is that the value of data grows as more data is added to the network. So if you can imagine a world where people were incentivized to contribute data into a common environment, the more types of data that get added to the network, and as these sort of multiple orders, level 1, level 2, level however many levels you can imagine, as this data starts getting aggregated, the higher order data, which is probably inherently more valuable because it's the synthesis of a whole bunch of different types of data, it actually drives the value, drives the demand for the lower order types of data and drives the value up. So, in the same way that in 1995 when we thought about the internet and all the different applications we could imagine, we couldn't have imagined blockchain. We postulate that if you start to put this data into a network, there'll be use cases that will emerge that are not obvious or intuitive to us today, which will drive the value of the data up even more than it already is starting to get driven up. So that's all good. That's kind of the theory behind this whole thing. Let's apply this to a real example. So we're driving home tonight. We're driving through lots of intersections along the way. Most people have seen the Italian Job and assume that intersections are already really sophisticated. I promise you they are not. They're basically glorified egg timers with analog globe switches in a metal box filled with air. So they're really expensive. There are lots of metal involved, lots of hand soldered backplanes, lots of load switches that fail, lights that need to be changed, lots of wiring to do it. So when you install an intersection, there's this big capital cost that you incur up front. And then because they're hard to maintain and things fail and you need to do a lot of manual traffic engineering to keep them functioning and keep the drive home a happy one, there's lots of operating costs. So if you look at an intersection over the course of, say, 20 years, 20, 25 years, which is the average refresh rate for infrastructure, The total cost of ownership of an intersection, depending on a few factors, ranges anywhere from $250,000 to $400,000, right? So, now imagine a company came along, say like Myovision, and let's say we had a technology way to make traffic way better, right? We can make it safer, we can make it more optimized. Because of the economics of my industry, it would take 20 to 25 years for the impact of that advancement to be felt because of how the government buys infrastructure, right? So the only way that I can, even if I have the solution today, it won't be, it will literally take the rest of my career to make the impact, right? I'm a very patient person. Some of the people who work with me and that are sitting in the audience will attest. So how do we compress the timeline that it takes to make this impact felt? So the idea is you can probably re-architect an intersection. It doesn't need to be a giant metal box filled with air, right? You could make it, literally make it into something that looks more like this. So that's one way we can drive the capital cost down. We can drive the operating cost down by using more software automation, reducing the various component types that can fail, making it easier to maintain and install. But that still doesn't get you to the point where you can really compress the timescale. So if we apply a protocol that can take the data being generated from intersections and make it available for people to purchase, right, to use in all sorts of applications, two things happen. One, cities can now monetize intersections in a way that we believe can drive the total cost of ownership of an intersection to zero. So basically, we can create an income stream in addition to reducing the capital and operating costs of an intersection that makes an intersection function more like a bus or a parking meter, right, where it can now be an income stream and can run cost neutral. But the other thing that happens is now you've created a whole new way for innovators to actually build businesses, right? Because there's data that literally wasn't available to them before. Real-time information about the performance of the traffic network that was only available through information you could get from Google Maps, for example. We can now get really high-resolution information, make it available through APIs, and business models can be built on top of it, which has its own sort of economic development effects. So we're really excited about it. We think that the protocol, and I'm going to get a little bit technical here, but I don't have any code, unfortunately. But we're really excited about this, not only in its application to intersections, but we believe that the model that I'm going to describe here applies to all sorts of classes of infrastructure that generate data that can be used to fundamentally change the economics of infrastructure. So this diagram here is basically, and this is sort of blockchain 101. So I won't spend a lot of time on this because most times I'm not talking to blockchain experts. But the traditional way that data, like intersection data, would be consumed by the market is you'd have a data aggregator who would come along and they would sit in the middle and they would basically buy data for cheap from someone and they would aggregate it all together. They would have an expensive business development process, a bunch of salespeople running around trying to sell it to the market, and they would try to keep as much of it for themselves as they could, right? So it creates a really expensive end user market, and it really provides no incentive for the person who owns the data to generate more. In a blockchain environment, you can eliminate the need for a middleman, right? So you can basically connect the consumer to the supplier of data through smart contracts, and you basically make it a market that's way more efficient. So what happens is the end user gets the data for cheaper, and the generator of the data actually is making a lot more money. So now all of a sudden they're motivated to go out and generate more data, right? So if our goal is to create an economic environment where municipalities, private sector, citizens are incentivized to add their data into this network, we believe that blockchain is the perfect technology to create an environment where you can eliminate all the waste, all the middleman costs, and push more of the profit to the people that actually need to go do the work to make the data available. So this is the most technical slide I have, so sorry for anyone who's technical. The first two layers of this, you can think of this as almost like an OSI network model. So the first two layers really, we're building our blockchain on top of the Ethereum network. So you can think of the first two networks here is really provided by Ethereum, right, out of the box, right? So security, decentralization, transactions, audit, all that kind of stuff is provided right out of the box by Ethereum, actively being developed. We get to take advantage of all of that active development by the community. The pieces that we're working on, and I would say the most important piece that I'll spend a little bit of time on, is this notion of price discovery. So how much is data from intersections worth, right? No one knows, right? I can say it's worth something, but I'm probably wrong, and I probably either priced it too high and I've locked a bunch of people out of the market, or I priced it too low and I've left money on the table. So a lot of the work that we're doing is, if anyone's seen the movie Beautiful Mind, Nash Equilibrium, basically using tried and tested concepts from auction theory, and then applying them into a blockchain environment where we can basically use supply and demand, like tension that we can simulate in smart contracts in the market as a way to discover the underlying value of a given schema of data, right? So how much is the intersection data worth at Glasgow and Belmont and Kitchener? Well, we can use this sort of auction method to discover that price. And if a brand new subdivision goes up down the street, well, the value of that data might go up. And this model is dynamic, and it would sort of continue to learn over time the changing value of that data. So the closest analogy that we can think of when we think about this is sort of, Google had a great search engine, but that's not how they became Google. They became Google because they figured out how to price search terms, right? And for a long time the word Uber wasn't really worth that much, and then all of a sudden it was. And so we're sort of applying the same thing where we start with an arbitrary schema of data from a piece of infrastructure. We register the existence of that data sort of in an index, and then our auction system kind of takes over and watches for market signals and prices the data. Our notion, we have a similar notion of mining, but it's more based on sort of providing the utility in the network. So someone has to run those auctions. There's a whole bunch of, I won't get into all the details, but a whole bunch of, mechanisms, escrow mechanisms and trust mechanisms that we sort of built into it. So there is kind of a notional mining concept, but not really the same as an Ethereum mining concept where you're securing the actual network layer. This is about basically securing the economic layer, like the rules of the economy, the central bank, if you will, how this all works. And then the last piece is discoverability. So once we have all of these devices that are generating data registered in the network, and we have some price discovery happening around them, we have to make them searchable, right? So if you think about arbitrary schema types of data from places all over the world, that problem becomes very complex, very, very fast in terms of how you actually find the data if you're a startup company somewhere in Waterloo that wants to use the information. So that's where we're spending a lot of time these days. And our first application is going to be on top of the products that we already sell to customers out in the market. But we're hopeful that through partnership and through expanding our own product footprint, we'll be able to apply this to all sorts of different places inside the smart city. Really quickly, if anyone's been following some of the stuff going on with Sidewalk Labs in the Quayside project in Toronto, stuff that traditionally has been left to the technophytes like us to deal with is now all of a sudden raging public policy debate, right? So technology is becoming more and more pervasive in our city, but it opens up all sorts of questions about surveillance state and privacy and ownership of data. And so one of the things that we've been spending a lot of time on, not only with contemporaries in the SME space, but also with government officials and with sort of NGO groups, is really trying to pin down what are the governance, like what are the public policy principles that this technology needs to be based upon. Because if you're not careful here, you end up building a very dystopian economic model. And so we want to make sure we get this right. So we're working with probably about 40 different organizations right now across sort of the public, private, and NGO space. We've identified these 6 what we're calling principles, and we're spending a lot of time right now convening those groups in various formats to try to flush this out, right? So what do we mean by privacy? What do we mean by aligned incentive mechanism? What do we mean by scalability? So in the coming months, we're going to be publishing some work on sort of a policy document in effect that sort of tries to link technology and public policy and put it out there. And the hope is that we get some of it wrong and that elicits a reaction and that we have engaged public and or private stakeholders that can kind of tell us where we might need to refine this. And then this becomes, in effect, a roadmap for the protocol, at least at a principles level. That's kind of it for the presentation. This is not an architecture slide, just for any people who might have been accused of me of being a bad engineer. So I don't know if it's appropriate to take questions or not, but if not, thanks for listening, and happy to chat afterwards.
Thank you, Curtis. Does anybody have any questions before we move on?
It is known that Ethereum has issues with scalability. So with so many devices, you need like a sidechain or some other solution.
Yeah. I feel like I should just point to that guy and say.
Wait, actually, I think.
Yep. Sorry, I was going to say, so we're actually right now running a fork of Ethereum in a federated network, and we're finding that at least it doesn't necessarily solve the scalability problem, but at least it solves the cost-related scalability problem. At some point, we're kind of hoping that the Ethereum community, and maybe we help with that one day, but we're hoping that the Ethereum community sort of solves the scalability challenge. But for now, we're kind of running it in a private chain.
And I think scalability is one of the topics that will come up in the panel as well, so we will touch on that more as well.
Another one about the gas prices, how Ethereum is not free. There are other blockchains, for example, EOS, that's cheaper.
Yeah, so like we're in the early, I think we're in 1996. If we made the analogy to like HTTP. So I think we picked Ethereum for now. I mean, there'd be some porting cost to move it to a different blockchain, but I mean, I think Ethereum is actively being developed. We're seeing even from in the 6 months that we've been actively working on this, we've seen the comment earlier about how it's the worst programming language ever. I've heard that exact comment in our office almost every day. But they're fixing bugs all along the way. So yeah, I think we'll see how this all shakes out. But we've looked at a few different like Stellar and a few other ones that they all have pros and cons.
Yeah, any other question? Oh, Martin. Uh-oh. This could be a difficult question.
No, we have not performed a security audit yet.
No. Well, not be a difficult question. So, when it comes to security of things, many software security assumptions come with the basic assumption that nobody has physical access to the device.
Mm-hmm.
Because once I have physical access to the device, I can start plugging my USB keys into it and installing my software and intercepting network communication, all of that, right? So when you are saying smart intersection or smart device somewhere in the city that is in the public space, technically everybody has physical access to it.
Yep.
Are you thinking about those issues and are you somehow tackling those?
So I'll start your question by giving you a fun fact about intersections. Every single intersection in North America uses the exact same key. The number 2 key. So you can buy them on eBay if you ever want to break an intersection. That's the current state of security in North America intersections. So our goal has been to be better than that. Hopefully a lot better. So no, I mean we think we have done a lot of security audit on our we call traffic link, but on our intersection control product, it's all cellular and cloud based. So if someone could get the number 2 key and connect an Ethernet cable to our device, then in theory they would have access to the network. So we've done a lot of sort of white hat hacker security auditing on that product. We're not mature enough with the blockchain stuff to do security audit, but we've identified that as one of the things that we definitely need to do. So we should probably chat at some point because you seem like we already do.
Sounds good. Thank you.
Any other questions for Curtis? All right, can I get a round of applause then? Thank you very much, Curtis. I don't know, a lot of the people who came to present tonight, we all came from Toronto. I was actually raised in Cambridge, but we drove down from Toronto. So traffic is a real big thing for us. And actually, I don't know how many people heard this, but Toronto was recently rated as the 3rd worst city for traffic in North America and the 6th worst city for traffic in the world. And so, Myovision, please, Myovision, we are waiting and we are hoping, for the solution to come. Really looking forward, and actually very proud that Myovision is a Waterloo startup, Waterloo company, and again, this community just bringing so much to the world. So very excited to have Curtis here, and really looking forward to the future that Myovision brings, and the integration of blockchain technology that offers. So, the last portion that we have tonight, I know we're running a little bit late, so maybe we'll speed up the last part, but we have a panel. So all the panelists in the room, you know who you are. Can we get you up to the front here, and we will start a discussion, and I encourage any audience members to try to make this as dynamic as possible. So if you have questions, feel free to put up your hand. I will be moderating the panel. I can come out and reach you, and we will keep this as relevant as possible.